Hello everyone, this is the last lecture of this course, lecture 36. Here we will talk about the summary and course wrap up. So, we have started this course with very basic example of foundation of the climate science, and we talked about what is exactly climate, then we have talked about what is exactly weather, then we have discussed about what is the difference between climate and weather, right, and then we gradually shifted our idea towards what is exactly climate change, how we can relate the climate change with the natural processes, how we can relate the climate change with the anthropogenic activities, or why we are saying that climate change is purely responsible because of the human activities like that. So, that is all we have discussed about in lecture 2 in the beginning of this course. Then basically we have talked about what is exactly climate extremes, how we can define those extremes, what are the different types of extremes and global impact or regional impact. So, this kind of the very broad understanding of the climate extremes we have discussed, and why. So, the first of all, it is important question that why we should learn about climate extremes, then that is also we have discussed during that particular lecture. In the week 2, we have primarily focused on the types of and characterizations of extreme events. For example, we talked about heat waves, we then talked about cold spells, and then we also talked about what is their causes, what are their impacts, what is their trends. Then in the further lecture, we talked about what is extreme precipitation event, and what is the consequences of these extreme precipitation events in terms of floods and droughts and let us say water cycle impacts. Then in the next lecture, we further discussed about let us say more different types of extreme events like tropical cyclones, what are their storms, and then how these associated weather extreme events are responsible for multiple process, or basically multiple types of socioeconomic conditions or impacts are produced by these particular different types of extreme events like that. Then in the third and fourth week, we have primarily discussed about what is the tools and what is the techniques which are available currently for observing and measuring the climate extremes. So, in the first week 3, we have discussed about observing and measurement of the extreme events. For example, we have talked about different types of climate data sources and observational tools. For example, we have talked about satellite, ground data set or ground stations, and the remote sensing data set, and why we should use integration of all these 3 data set as a hybrid data and to use for global kind of study or global or regional studies like that. Then in the further lecture, we talked about what is the data collection process and pre-processing steps. For example, let us say we have missing gaps, we have gaps in the data, how do we handle that gaps. Then we talked about what is the errors in the data set, how we can address those errors in the data sets which we have collected from different sources, and let us say what is the temporal biases, spatial inconsistencies, how we can address those errors and uncertainties in the data set within that particular lecture. Then we have also talked about multiple types of data producing models, climate models, which can give you the information about future climate data set, what is their types of models, what is their resolutions, what is their applications, because when we are talking about let us say satellite, ground observation and remote sensing, it will only give you the information of the historical data set, but when we are talking about the climate model, it can give you the information about what is likely to be happen in future climate conditions under different warming scenarios like that. Then we have talked about statistical foundation for analyzing the climate extremes. We have discussed about what is exactly probability distribution function, how do we use this probability distribution function in the climate data analysis, what is a CDF, what is the probability, what is the probability densities. These are the kind of the information we have already discussed in week 4 lecture 10. Then after that, we have discussed about how do we introduce the extreme value theory, how do we handle, for example, extreme climate events with your different sets of probability distribution function, which can be extreme value theory EVT, and how we can use this EVT for different types of purposes. Then we have also discussed about how we can use this extreme value theory analysis for frequency and intensity of extreme events, and how we can use these different types of specialized distribution functions to calculate the probability of occurrence of these different extreme events and their behavior overall. Then in the module 3, or let us say week 5 and 6, we have primarily discussed about analyzing and detecting the changes in the climate extremes, which is basically detecting and attributing the changes in the extreme events. We have talked about how do we do that time series analysis, how do we do that trends, how do we do that seasonality, stationarity and correlation. Then we have discussed about how do we detect the changes in the extreme events, or some sort of statistical techniques, or inferences based techniques, or correlation based techniques, or multivariate based techniques we have discussed about. In the lecture 15 in the week 5, we have also discussed about how do we attribute those studies or linking extreme events to, let us say, anthropogenic climate change, or different types of processes we can link it together, and we can get an idea about whether a particular type of process is actually responsible for exaggerating the climate extremes in a certain regions like that. In the week 6, we have further discussed about risk assessment and return period calculation, why it is important. Once we have understood about the process and what process is responsible for different types of extremes, it is also equally important that we have to also calculate what is the risk of certain different climate extremes. So, we have discussed about risk assessment framework for extreme events. Then we talked about how do we calculate the return period for rare events, for example, 100-year frequency of floods or droughts, or extreme rainfall events, or cyclones like that. Then we have also talked about how do we address the uncertainty issue in the climate projections and risk assessment, because there are so many different types of uncertainties can be present in the projections of climate model, and that can be accommodated while we are discussing about scenario based assessment of impact assessment of different warming levels like that. Then further we have discussed about different types of case studies. Case studies we talked about 2013 Uttarakhand and 2015 South Indian flood, where we discussed about the specific details of these different events. And then we have talked about how do we learn from these particular extreme events case studies, and then we can prepare ourselves, or in terms of installation of the early warning system, or installation of let us say data collection devices or like that, because if you have data set, we would be able to tell a lot of story and lot of better management of these extreme events in certain regions like that. Then we have also talked about millennium drought conditions of Australia, what are their factors, how many areas are affected, what are the steps Australian government has been taken to overcome that kind of the problem in the future steps as well. And then we have talked about 2022 heat waves which are across northern and central India, and what is the lesson we have learned from this particular extreme events, and how do we mitigate if any similar kind of event will occur more frequently, and how we are prepared with different types of socioeconomic impact model that can minimize the risk of these particular extreme events across Indian regions like that. Then we have also discussed about predictive modeling of extreme events, where we talked about how do we use statistical and machine learning model to predict the different extreme events in the future, or historical period of scenarios like that, or given any given scenarios like that. Then we have also talked about how do we build and validate the ML based model for predictions. Then we also talked about how do we use that already built up ML model for scenario analysis and projecting the future extremes. Then in the module 5, we have primarily focused on the socioeconomic impacts, vulnerability and policy response. There we have primarily discussed about what is the socio-economic impacts and vulnerability to extreme events, particularly economic of cost of extreme events, damage and recovery. Then we talked about health and social impacts of the climate extremes. Then we talked about the vulnerability and adaptation in the developing region particularly. Then we have talked about international agreements and national policies on climate change. And then we also discussed about then we also discussed about risk reduction strategies and community resilience. Then we also talked about the adaptation policies for climate extreme events. In the last module, particularly module 6, we have discussed about primarily the emerging trends, advanced applications and future directions of the climate extremes. Here we primarily discussed about the emerging trends and advanced topics, for example, advanced climate data, climate extreme research and big data applications. Then we talked about how do we use that remote sensing and AI in detection the climate extremes. And then we talked about how do we input or account the role of ecosystem in mitigating the extreme events for example mangroves or for coastal flooding and all we have discussed about. And then we have also discussed about in the last week of this course the review of the statistical analysis, which are very important to analyze the extreme events or analytical methods, and then we can integrate some sort of case studies how we can analyze recent extremes in different parts of India or different parts of the world based on step by step procedures. So, this is overall we have discussed the whole content in this particular lecture. We have started with the very basic, we have discussed primarily the statistical and analytical methods. We have also discussed about the data sources and then how we can integrate in the modeling. We can also discuss about how do we address the issue of uncertainty and data gaps. We have also discussed once we have set up the model, how do we convey the results which we have observed from the modeling to the local government so that they can make some sort of policies out of it and then implement in that particular region. And then we also discussed about, let's say, what are their advancement in the climate extremes area, so that it would be helpful for to know the unknowns which we have not uncovered so far. We can use it for the advanced technology and then we can use it for multiple different analysis like that. So, this is the overall course content we have already discussed in different lectures in different modules like that. In this lecture, we will also summarize whatever we have discussed in week 12 and very briefly and what we have learned so far in the week 12 like that. So, we have started with the very important descriptive and exploratory analysis, where we have talked about statistical measures and box plots and time series and histograms. Why it is important? Because graphical representation of the data set is very important thing. If we have the data, if we can graphically represent that, that would convey a lot of stories out of from the data set itself. Then we have multiple types of analysis. We have discussed trend analysis, seasonality decomposition, stationarity test or autocorrelation analysis that can give you multiple insights about data. For example, data direction, break data into different components, what is the data stationarity, which will also investigate the past influence on climate current values or climate data set like that. Then we have also discussed about the probability distribution function and extreme value theory. Why it is important? Because it will give you pathways to basically predict how we can get an information about 100-year flood magnitude, let's say, or 50-year flood magnitude, or let's say the frequency of a certain thresholds if it is crossing above. That kind of the information can be done by extreme value theory, and it is very important for in terms of planning of, let's say, 100-year flood protection structures, infrastructure design, disaster preparedness or urban planning, or some sort of heat waves predictions or mapping of those areas which are significantly affected by heat waves occurrences like that. Then we have also talked about multivariate analysis, because why it is important? When we have multiple variables, we will not be able to, so whatever you see in the natural world, all the variables are interacting with each other. It is not like that only one variables with interacting with each other and gives you bivariate relation all the times. Most of the time in the natural world, we are observing the multivariate interactions. Therefore, we can use multivariate analysis to get an idea about how multiple different variables are interacting with each other, and how we can take this information to to advance our climatic streams research in terms of their predictions and their understanding and all. Then we talked about Kapula based method, which is one of the most advanced methods in the climatic streams, and can be used to merge the probability distribution function into a multivariate distribution function, and that can be used for different return level analysis or process interpretation or their relationships like that. That can be done using these kind of the multivariate analysis. Then we have machine learning and AI techniques that can be used to predict the nonlinear behavior of the data, and can give us an idea about how we can use these machine learning and AI tools for clustering of the data set, and can give you an idea about how a different area are behaving in how they are behaving in the different climatic extreme conditions, or what is the overall region which are hotspots in a certain climatic extreme conditions like that. Then we have also discussed about, let us say we are setting up some sort of machine learning model. How do we break the data into two parts, validation and calibration, and then we can use that information to check the accuracy of the model, and then the most accurate model we can select. Out of that, the most accurate model we can use it for projections and predictions of the climatic streams. That will give you the minimization of the uncertainty whatever we are getting for the future scenarios or for the predictions, because if you use the most robust model or validated model, it will give you lesser uncertainty compared to other models like that. Then we have also discussed about data processing and cleaning. That is also very important step, because it might possible that we may have some sort of data gaps or missing gaps or spatial inconsistencies, or let us say temporal biases that can be removed by different types of methods like that. Then we have also discussed about after these steps we can visualize our analysis using some sort of mapping software, some sort of time series software, or let us say making a time series plot, or some sort of spatial data plot, and that can give you idea about let us say what is the total spatial coverage of the climatic streams in a certain region, or let us say what is the temporal fluctuation of the climatic streams in a certain regions like that. So, that can be done. Then we also basically discussed about what kind of the method we have to choose when we are talking about different types of climate extreme analysis, whether the spatial data method we have to go or we have to talk about temporal data, what kind of the method we have to select, for example probability distribution function, or we have to go with the Kapula method if you have multivariate event. So, basically when we are talking about the climate data analysis process, we have to talk about some sort of exploratory analysis, which could be descriptive statistics, which could be cluster analysis, which could be correlation analysis. Then we move towards the predictive analysis, time series forecasting or supervised machine learning forecasting, or let us say regional pattern, which is also we are trying to simulate using the machine learning or different statistical tools. And then after that we try to statistically infer, and then we use for some sort of uncertainty quantifications. So, suppose if we are trying to look at a case study, here basically we have to look at define objectives, then we have to list the potential events, then you list what is the documents which has been already available. Then we can look at the data availability, we can look at the evaluation and relevance, and then you can basically select a suitable case study for analyzing the extreme events in a certain regions like that. Then we can start thinking about data collections. We can use data source from the ground observations data set, you can use the satellite data, you can use reanalysis product data, or you can use climate projections data set. You can aggregate the data, perform the error analysis, normalize it, and use it for your modeling purpose like that. Then you can use the data for different types of statistical analysis. It could be anomaly detection, it could be descriptive statistics, it could be data visualization, it could be trend analysis, it could be result interpretations like that. And then you can basically for the, let us say if you are working with the return period estimate, you can identify the extreme variables, we can fit the probability distribution function, and then you can estimate return periods. you can visualize the results, and then you can talk about how different types of return periods have been changed or basically behaving for different regions as well. Similarly, you can do for multivariate. By only replacing, you have to work on the joint probability estimation, and that will give you the information about your return period estimate. And for the machine learning, you have to basically identify the objectives, prepare data set, choose model, then train the model, evaluate the model and tune the model, and then use that model for your forecasting the events like that. And then finally, once we have all these things are ready, you will be able to do some sort of visualization mapping analysis, where you can try to look at how your maps and data sets are behaving for different regions, and that will give you information about overall analysis what you have done for these climate extremes. And then the most important part is basically, once we have already plotted the results or analyze your data set, we have to interpret and discuss what would be the implications of these results, what would be the case study you have taken up for that climate extremes, how you can correlate with that case study with global perspectives, or let's say how these case studies which you have done can contribute to the local policy management, or basically motivate the local government or local policymakers to make some sort of more adaptive or change the policy so that they can take into account the changing behavior of the climate extremes in that particular locations. Or let's say how a climate extremes analysis of one particular locations can be helpful to guide or reshape the international policies which global parties are making. Suppose UN SDG goal or UN FCC goals like that. So that is basically can be done by discussion, interpretation of the results, and if you have new findings, new interpretations, that can be written in such a way so that most of the people or large diverse background of the people can understand your analysis and can be applied for multiple areas and then you have to also reflect the limitations of your results, so that future studies should be planned accordingly, and that can fill the gap which has been created after your studies like that, or maybe you particular case studies are not able to fill that gap because of the data limitation or technological things or like that, but in the future studies you can mention it, and then future studies can basically try to fill that gaps like that. So this is overall we have discussed in the week 12, and how do we we review all the statistical method and analytical method, and then how do we take up you can take a case study and you can analyze it, and you can step by step you can do different procedures and try to discuss about your findings with your broader audiences like that. I hope in this particular course you have learned many things about climate extremes, how do we analyze the climate extremes from the observed data set or projected data set or climate predictions like that, and how we can use climate extremes information for different types of planning and management and policy making kind of a study. How do we do that if we analyze a case study or broader region? You have to basically discuss about your findings with the broader audiences in a such a way that it can be impactful and it can relate with multiple different processes at that particular regions, and also highlight the gravity of the problem or impact of the climate extreme in that particular region. So that is very, very important, and that will give you a more better message about how we can manage the climate extreme for the future climate or the current conditions like that. I really thank you everyone who are listening to this particular course, and I also wish you all the best for your future endeavors. Thank you so much.